All right.
So if I was a pencil, where would I go? There. Hello. All pink today?
I got a check.
What am I doing? I'm looking at the time. You got it, let's check it together.
Wasn't one of those, but I said Al.
And this was Weissler, so we got it. Okay, you're good. Thank you very much. Today's lesson is going to be easy for a lot of you and difficult for some of you. It's a review lesson. We've already learned it, but you probably were better at it last year than you will be this year. Huh? That's a good question. And the answer is because last year you probably do your identities better than you do this year. If you don't know your identities, as they say in Brooklyn, forget about it.
You know, there's like
Yes, I know.
I love it.
There's a sandwich.
So if I were to write this equation on the board, r equals 2 sine 2 theta, you would know that's the equation of r.
Oh, I was going to say.
You would know that's the equation of
Polar
r.
rose.
Good. With how many petals, John?
4.
Yeah. Good. That was r, write this please, r equals 2 sine of 2 theta. So imagine you've plotted that polar rose, and the sign types generally are in the quadrants rather than on the quadrantal values. So imagine you've graphed that one, and I said this is the second equation, r equals sine theta, 2 sine theta. 2 sine theta is the equation of r.
Circle.
Good. And where is it located?
On top of polar.
Good. What's what does the 2 represent? Heck, could you try to draw those two together on one coordinate system? It doesn't have to be perfect, but you have a sense of what it looks like. As soon as you're done saying done. What we're going to do is now solve algebraically trigonometric. Since they're both in the form r equals, what are we going to do to solve? Since they're both in the form r equals, Ben,
Set them equal to each other.
so what does it say?
2 sine of 2 theta equals 2 sine of theta.
There. So algebra. Obviously.
Why is it too close?
Why is
it on there?
I wasn't.
Oh, they look like a clock.
What is if you were paying attention? That's why.
Okay.
And obviously,
Sine of 2 theta is 2 sine.
no, obviously. First before that.
Right out the boots.
Heck
Yeah.
See,
I think you should have done that already.
now, obviously or not, if you don't know the sine of 2 theta, you're toast. Forget it. You're going any further, you get nothing. You can guess and check all you want, but you're not doing it. So, do you know it?
Yeah.
Write it down. Are you like? Did you like have funny pills? Or
I'm
something?
just nervous.
Okay. Yes, go ahead.
2 sine cosine.
2 sine.
Of theta.
Ah,
Times cosine theta.
good. Next step. Yes.
You're gonna subtract because otherwise you could lose an answer.
Heck,
You're
yeah.
not.
Something's going on with this computer. It's not happening.
So
Oh.
2 sine of theta
Then it ends up saying.
minus sine of theta.
1 minus 2 sine. No.
Not yet. Be patient.
All right.
There's more.
Okay.
Is equal to 0.
Algebra. Algebra. So what's the algebra? Thank you. Sine theta times. What else?
Minus.
Heck yeah. Theta. Sine theta is 0, so theta equals. It does. You could also say 360, but it's redundant with 0 degrees. Cosine theta equals. Try again. Cosine theta equals.
1/2.
Thank you. Therefore, theta equals.
60 degrees.
And.
60 and 3.
These are not the answers to the question, but we're very close to the answers. These are the perhaps the angles at which they intersect, but not the points. The point has to have an r and a theta. So for example, if we use the angle 0 degrees, we need to mention its r. Which equation would you like to use? You should be able to use either one. Which equation would you like to use? Yes?
R equals 2 sine theta.
Okay.
Because
I think that's the easier one. So for that equation, at the angle 0, where are you?
0.
0.
Let's go to 180. At that angle, what's the r?
0.
I need somebody to say something. Yeah,
Redundant.
good. So I'm going to put a line through it and write what you just said. Meaning it's just another way to say the same point. We don't have this as two different points. For this one now, again, our angle is 60 degrees, but we need to have its location on the 60 degree ray. This is the easier one. And we get,
Square root of 3.
why just the square root of 3?
Because multiply by
Two
2.
sides.
And let's go with that other one, 300 degrees.
Negative.
Negative square root.
And I need for you to think now, because thinking is good. Are these redundant one with the other? He said, and they said no.
No.
Two words?
No.
This one clearly is in which quadrant?
First.
Which one is it?
Second.
Very good. So they couldn't be the same. They're actually naming two distinct points. You see three distinct answers. Look at your graphs. Does it look right?
Yeah.
So I don't know if you remember this from last year, but sometimes when you do the algebraic / trigonometric
Because I grasped.
Cosine.
solution, you don't get to see the pole as a point of intersection. And it's because one of the curves is reaching a pole at this angle and another curve is reaching a pole at a different angle. It didn't show up in the solution. Visually, you'll have to state, okay, that's also included in that. Well, somebody had a question.
Why is it not redundant?
Pardon me?
Why is it not redundant? You got it.
Plot this point. What
Yeah.
quadrant are you in?
What?
Plot this point. -3 on 300. 300 is
Oh, fourth. So then it goes second.
how could something in the first and the second be the same?
Oh, yeah. I got it,
So let's try another one. Do this one on your own, please. Here, forward back. This time do the algebra / trig solution first and the graph second. R squared equals 2 cosine 2 theta, and R equals cosine of 2 theta. Different approach. There's almost no trig in this except at the last stage. There's almost no trig in this one. If you're thinking of the identity for cosine 2 theta, stop thinking about it. Not an issue. Capiche? So this time you have to start by setting
R squared equal to cosine squared of 2 theta. Then we can equal.
almost correct.
Square R and cosine 2 theta. And then
Isn't
set.
that what you just said?
That's what I.
That's what she just said.
You said
No, she said make r squared equal to cosine squared.
Oh, okay, so you were looking only at the second equation.
Yeah.
I was expecting someone to say r squared equal r squared instead of r equal to r. That's what I was looking at.
I heard what you.
Yeah, I did R squared.
Okay, so, and then of course you get it equal to 0, you factor out
Cosine.
cosine theta.
You draw the line, you get the other factor, you draw the line. So what are the two things cosine of 2 theta could equal?
0
And?
2.
Good. What's your conclusion?
Can't
Can't
even
equal
do.
to
Say again?
Can't even do.
Why not?
Because it can't be greater than
Because it's, cosine is adjacent.
Because the leg can't be bigger than that one.
Certainly correct. So reject that one. Did I write the wrong thing here? Where did you get 2 from?
I don't know, I got one.
No, because it's
No,
minus
it's
2.
2,
Minus
minus 2.
It's minus
Oh, I
two.
wrote the wrong equation.
Oh, come on.
And now I see what you got to do. Look at that, there's a pink elephant up there.
Where?
Yeah, that's it. It's just like.
I am sorry. So cosine 2 theta should have equal cosine squared of 2 theta, yeah? Cosine squared of 2 theta minus cosine 2 theta equals 0. Factor out a cosine 2 theta and you get what?
Took out the 2.
Cosine is with 2 theta.
That's minus 1.
Bless you. Okay, I'm sorry. So for this one, if cosine theta 2 theta equals 0, what's theta?
90, 270.
Good. Angle of 2 theta could equal,
90.
or angle 2 theta could equal,
270.
heck yeah, implying that theta could equal,
45.
and
135.
for this one, when does the cosine of theta equal 1?
0.
Again, or 360, but yeah, 360 is an issue. So 2 theta this time could equal 0 or 360. Since we're going to divide by 2, this becomes a value for us.
Yeah.
So theta then could equal,
0
0.
or 1.
1.
and please write degrees in each of these if you are doing this in degrees. So we have to get points now. Again, you're not done when you get the angle. Sometimes they're redundant with each other, as we saw, sometimes not. I think this might be the easier equation. So cosine of 90 is 0, done. Cosine of 2 of those is 270, 0, done. Redundant. Do your work? No. Redundant. Redundant. That should work. 0. Cosine of 0 is
1.
and cosine of 360 is,
180.
What?
I'm sorry, I doubled the 180, I got 360.
One.
Same or different?
Different.
Different.
Thank you. So, again, we do have the poll here. I'd like you to graph this, but not right now. I'd like to have some time, a little bit, to go over the test as well. So I'm going to jump to one more question. Any question on what we just did? So r squared equals the square root of 3 sine of 2 theta. And r is equal to square root of 2 cosine of theta.
Oh, are the numbers correct?
Pardon me?
Are the numbers, is it right? Okay.
Oh,
good job.
Whoa, what just
Got it.
I don't know. I have no idea what's that line.
No, I was wondering.
What's the mistake? I make mistakes, I'm a human type person. What'd I do? Tell me, what'd I do?
No, nothing.
Before we looking at
Chicken. You think it's the square root of 2 and square root of 3? Maybe it's mistake. Maybe it is. Maybe it's not.
You won't tell us.
Okay. Anyway, so we said r squared, kind of pushing this, equal to r squared. What's r squared?
2
cosine squared theta. Get it equal to 0, square root of 3. And what are you going to do with the sine of 2 theta?
Change it to
Change it.
To what?
2 Sine 2 theta times cosine 2 theta.
Two sine theta cosine.
No. Sine of 2 theta, you're gonna change to,
2 sine
Two
theta
sine
equals
Two sine theta.
Oh, well,
Sorry.
Happens.
you got still 2 thetas in there.
yeah.
And then you take away the
Get rid of the
2.
twos.
By the way, now that we don't get rid of it. Now that we change this using the identity at this point, not at the point I'm pointing to, but at this point certainly you could divide by 2 on both sides. Yes. 0 could be divided by 2, this side could be divided by 2, so you 2.
Right.
From what's left, what can you do?
Factor.
Out.
Cosine 2 theta.
Imagine this 2's been divided out, it's not there anymore. So what's this?
Square root
Square
3
root of 3 times.
minus cosine theta.
Thank you, that's correct. Equals 0. So I'm gonna skip a step. Cosine theta is 0, we did this already. Theta could be
90 degrees.
4.
4.
270.
If, let's do this one. So this time, what does this yield?
So it's
Remember what to do when you have this?
Square root of 3.
Tangent of 1 over 3.
Alright, that'll work.
1 quarter.
Not cotangent of 1 over
Theta.
3, cotangent of theta
Oh.
equals 1 over square root of 3.
Yeah.
He divided both sides by sine of theta.
Equals
Okay, good.
square root of
Or the tangent of theta equals square root of 3, same question,
Yeah.
yes?
No, it's
No, it's
cotangent.
cotangent.
It's cotangent
Cotangent
equals
equals
square root of 3. And tangent
Yeah.
equals 1 over 3.
cosine over.
Yeah.
Yes, that's correct. So let's leave it as tangent.
Yeah, that's what I
So tangent of theta is 1 over square root of 3,
30.
yielding what angles?
30
And-
210.
Thank you. Okay, and then you plug it in and you finish. Are we done?
Yeah.
No.
Then you plug it in.
That was implying you could finish this on your own, the thinking is done. There's a little bit of trig, that's all.
That's
Just a
it.
little bit of trig. Tomorrow's lesson, it's good that we have 2 periods, we're gonna be performing a process called finding the length of a curve. So we did that,
We did that already.
but not the polar curve.
Oh, yeah.
And it's gonna have to do with something we call a radial sweep. Imagine if it's a circle and we're going from 40 degrees to 50 degrees. So you do a little sweep, you're a little part of the circumference. We're gonna look for that length, yes? But it's gonna be at any polar curve. And we'll sweep from one angle, a beginning angle, to an ending angle, and see how long that section is. It's not a line, whatever it is. Okay, it's later. Class did remarkably great.
Stop this now, right?
Kidding. Good.